what's going to happen when we run it then is you can see a bunch of numbers flying by. So when we run it, we see a bunch of numbers flying by. It's numbers, just lists of numbers going and going and going. Let me just pause the scrolling for a minute so we can see what we have here. So if I go in here, we see we have numbers like 1904, 732, 24, 384, 2144. These are the number of microseconds that the Arduino is counting between rising edges of pulses. So we essentially have it here. In a very short amount of code, we have the Arduino doing the timing that we want. Again, the interrupt that I showed you in the code here is programmed to trigger every time there's a rising edge. And rising edges are just one of the key defining characteristics of the pulse. There's the rising edge right there. So if I have it spitting out, looking for rising edges and spitting out the time between them, well, those are my times right there. So these are essentially, a little focus here. Those times that you see then are the continuous waiting times between gamma ray emissions. So I see a 224. That means there was a gamma ray, and 224 microseconds later, there was another gamma ray. Then I see an 1820. That means after that gamma ray that generated the 224 left, another one arrived 1,820 microseconds later, and then another one 2,720 microseconds later. So essentially I have a very long list of the waiting time between gamma rays. And that number should somehow be correlated to that 650 that we saw on the scaler. Now it's 0 because it's off, but there should be some sort of correlation between them. And so the goal of this experiment then is to analyze this long list of numbers here. I'm going to give you a huge list of these waiting time between gamma rays, and we're going to analyze them, and there's some very nice statistical theory that underlies it all for so-called waiting time between these events.